Hi, everyone. Thank you for joining us for our next live stream. I'll be your producer for this session. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional, and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters to answer live. Our session is being recorded. It will be available to view on demand right here on the Reactor channel. With that, I'd love to turn it over to our speakers for today. Thank you for joining.
Hello and welcome to Design and Develop Database Solutions. My name is Jeff Taylor. I'm a Microsoft Data Platform MVP and Principal Consultant. I run the JAX Data User Group and also the Jacksonville Day of Data events here in Jacksonville, Florida. There's my LinkedIn profile and my Twitter X handle, my blog, and my email if you have any questions and want to reach out. Along with me today is my co-speaker, and I'll let you introduce yourself.
Hi, my name is Olivier van Steeland. I am a Microsoft Data Platform MVP from Belgium. I work as a data architect for a company called DataShift in Belgium. I'm a regular speaker at data conferences and user groups, and I'm currently president for DataMinds, which is the Belgian data user group, focusing on the Microsoft Data Platform. That's from my side.
All right, so here are some upcoming and past sessions for the SQL+AI developer, DP-800. You can register and watch these on demand. You are watching one right now.
Do make sure that you take a look at the short link, that you scan the QR code to stay up to date as well, and to watch them on demand later on. So if we take a look at the, well, if you have never heard about Azure Data User Groups, it might be very interesting to take a look at. I often have chats with people who ask me for advice or where I learn new things, where I find new career opportunities, how to extend their own network. Well, personally, I started to expand my network over a decade ago by joining and visiting local user groups. To make sure, so just make sure that you check out where to find your most local Azure Data User Group. For example, for my case, thanks to local user groups, I got to meet new like-minded people, expanded my network, and it even might help you to get a new job. So
and for those of you attending, why don't you go ahead and post in the chat, let us know what user group you're a part of, so we can see where you are around the world. If you click on that link, it'll actually take you to a map that'll show you all the user groups in the world that are currently active. So that's pretty cool.
Right. Since you all seem to enjoy Fabric Data Days, which has been a while ago, we're bringing it back bigger and better, and SQL will be included as well. So you can get more information throughout the short link on your screen or by scanning the QR code as well.
So we have a moderator with us today on chat. So if you have questions, please put it in the chat there. Your moderator will be able to answer that, and hopefully we can get to all of your questions. So make sure you go ahead and put your chat in. Our moderator today is Philippa, and she is a Microsoft Student Ambassador. So thank you, Philippa.
So with all those practicals out of the way, what are we covering today? Well, we're going to take a look at a specific section of the DP-800 exam, which currently is in beta. And throughout the sessions today, we'll be sharing some topics which probably will be included in the exam, of course, without making any guarantees.
All right, so what we're going to cover today is we're going to cover the DP-800 exam overview. We're going to talk about design and implement database objects, which hopefully most of you are familiar with. We're going to talk about implementing programmability objects, write advanced T-SQL code, and then some AI-assisted database development.
Well, we just got something new in. Apparently, we are allowed to announce that the DP-800 exam actually just went GA, so general available. So that's pretty cool to announce, though. So what we are going to do today, we're going to take a look at the exam. And first things first, the exam is, well, really aimed at experienced SQL professionals who are moving into a world of databases and AI. At the core, and that's pretty important though, the exam really is about designing and building database solutions across any SQL flavor you can get with Microsoft technologies. So strong T-SQL skills will matter a lot. You're expected to know how to model data, how to work with relational data, handle semi-structured data, and so on. What really is new and important is the AI angle, of course. DP-800 really assumes that you understand the basics of AI concepts like embeddings, vectors, and models, and how to show up inside modern database solutions. This isn't about training models from scratch, but about implementing AI capabilities where the data really lives. The exam also will reflect how you will actually build the systems today. You need to be comfortable, though, with CI/CD by using GitHub, working with AI-assisted development tools, deploying and securing scalable solutions. Finally, and that's pretty important, though, DP-800 isn't really a solo role. It reflects real enterprise work where you can collaborate closely with application developers, DBAs, architects, AI engineers, and so on. So really think about the DP-800 exam as an intersection of SQL expertise, modern deployment practices, and AI-enabled database design. So if we take a look at the journey, there will be 3 domains covered throughout the full series. Today, we're actually going to focus on the design and develop domain, where every single phase throughout this full series will be built upon each other. So if we just, it's okay, that's a surprise though, it doesn't really matter. So for today, we have the design and develop database solutions. Then the second module will be implement data security and compliance. And the final one will be about implementing AI capabilities. Now, for today, we're only going to focus on that first module. Cool. Let's take a look at module number 1. So maybe before we get started, well, who is planning to take the exam in a few months? Or if you have an idea, well, I want to take it in the coming month, in a few months, this year, please let us know whenever you want to take the exam. Just let us know. So if we then take a look at module number 1, let's get started. So this is going to be, we're going to be talking about designing and implementing database objects. We'll cover platform choices, table design, indexes, and so on. So this really will be building the foundation. So if we take a look, the first thing we need to do is we need to choose the right platform for our task. So SQL Server, as you might know, runs on multiple platforms. Choose the platform based on your workload needs. It might be that your best solution is to go on SQL Server on-prem, which gives you a lot of flexibility in some kind of way. It gives you full control, but requires self-management, of course. It might be that Docker is the way to go for you, where you're able to spin up containers very fast in development and production. It might be that you might choose for Azure SQLDB or Managed Instance, which offer you a fully serviced product as a service solution with built-in high availability. What about Fabric SQL database? Fabric SQL database integrates with OneLake or also includes Copilot for AI-ready analytics. So these are some things you need to think about.
So let's talk about table design, data type, best practices. Those are key when designing any table that you have in your system. And it's best to make sure that you do that initially, because as I'm sure all of you know, the larger the table gets, the harder it is to correct any technical debt. So be sure to select the correct data type and size so that you can optimize your table on your storage and for your best performance. Also, normalize to third normal form and denormalize selectively for heavy workloads. So obviously, depending on your workload type, you need to make sure that you architect correctly. Microsoft always says that every table needs a primary key, and that's because of SQL Server's use of the primary key and clustered indexes to help you find your data as fast as possible. So be sure to always set one as well. So some of the different data types you may want to consider is, instead of, say, selecting a big int, select an int instead as far as your data types are concerned. One of the tricks I actually like to use is taking my int and actually starting at negative max int, which allows me double amount of IDs that are available in a identity column. Also, when using a date or date time combination, go ahead and select date time 2 and select the precision that meets your specific application requirements or data requirements. When doing so, you actually can minimize the size of that column in your table, and all of that data adds up over time. And if you're looking for a specific precision for, say, a financial aspect, use decimal instead of float. So let's talk about the different table types that SQL Server offers. So we have in-memory, which has two different flavors. You have in-memory, which is schema only, and you have in-memory, which is schema and data. This allows you to process data in memory. It never touches the table, or sorry, never touches the storage system. It stays all in RAM once you initially start your SQL Server. Then there's temporal tables. Temporal tables allow you to have version tracking. So you can see a timeline and history of the table as it has been changed or updated. This is also an awesome feature to have turned on in case of, say, someone deletes a table or some data without a where clause or updates without a where clause. You can easily go back and look at the table as of right before that update, and then adjust any changes or extract any data or update your table back to the way it was, which is really nice. Then there's external tables. This has been around for a while. I want to say 2019 this came out for us to be able to use Polybase inside of SQL Server, but allows you to reach out and connect to, say, Azure Blob Storage or S3 or Oracle with no data movement. So it literally looks at essentially a virtualized structure of the data, allows you to pull queries from that and see that data. I actually use this quite a bit when going to Azure Data Lake blob storage, and we can actually go in and query JSON objects straight from blob storage inside of SQL Server, which is pretty cool. Then there's Ledger. So this is a Temporal evident cryptographic verification, updatable only or append only, so that you can keep track of different items in your system. So either from a logging perspective, audit perspective, or financial perspective, if that's what you need. Then there's graph table types. So inside of SQL Server, you can actually create nodes and edges inside of a table structure, and then you can match them, right? So this is great for social or fraud detection, or if you're trying to find relationships between sets of data that you may not be able to obviously identify. So that's a pretty cool thing to use there. So a tip, match a table type to your workload, right? So keep that in mind. There are different table types for every workload, and every table type does not necessarily work optimally for all of your different workloads.
Right. So now that we learned all about different table types, well, as soon as we get started with it, it might get pretty important to know how to optimize your tables as well. One way, and probably the most important way, is by take a look at indexes, for example. And in all fairness, over the years, quite a few different options or index options became available. For example, we know, well, clustered indexes already exist quite a long time. Important there is you can only have one per table, and it really will define the physical sort order of your table data. So it really will define where a certain piece of data will be saved on the disk behind the scenes. Then we have non-clustered indexes, where there apparently is a limitation up to 999 non-clustered indexes. And these kind of indexes actually allow you to execute more performant lookups, for example, for very fast data retrieval. Make sure for example, that you know what the difference is between a clustered and a non-clustered indexes. Then, and I can't remember the year though, but I think it was SQL Server 2016, more or less. Microsoft introduced Columnstore indexes.
Actually, I think it was 2012 they started to. Maybe I'm wrong.
If you know, please let us know in the comments. So just let us know, share that information with us. So, but a Columnstore index was added as well, which had more familiarity with analytics, or analytics workloads actually, which is going to save your data in a slightly different way. Of course, there are plenty of options, so it might be a good idea to, after this session, just to take a look at those specific index types and just learn how to use them, when to use them, and just to know a bit more about them than what we can share in this hour session. Then there's something to say about filtered indexes, which is going to, well, with filtered indexes, you can index a subset of rows to target query, for targeted query optimizations. And then, for example, for very long texts, you can use full text indexes. And since SQL 2025, nowadays you also have JSON index and vector index. For JSON index, this really will help you to index your JSON data types. And then vector index, yeah, well, it is for your vector information. A vector index is a specialized index designed to optimize everything concerning vector data, commonly used with machine learning, recommendation systems, and AI in general. Then one tip as well, index columns, which are used in where clauses, in join conditions, and in order by clauses. This will help you for performance as well.
Yeah, and don't forget to use the include function sometimes. That's a really cool thing to add for your indexes.
Yes. Yeah, and I don't want to extend too much about it though, but not all columns are great fits to be an index. It might be more important to have them in the include, to include them in an index in some kind of way than have them in the real index itself. Anyway,
yeah, especially the larger ones. The larger ones you definitely don't want to index as much. So
then besides indexes, well, we need to talk about constraints as well. Constraints actually is what is going to enforce your data integrity when you're developing database solutions. There are a couple of different constraint types. You have primary key constraints, which will, well, make sure that you have a unique row ID or that you can define uniqueness for a certain row. It will provide a clustered index default, and it won't allow null values. That's pretty important here. Then we have foreign key constraints, where you can set up different kinds of foreign keys with cascade, no action, no check, whatever you can think about. And a foreign key basically is saying, hey, I have a reference to a specific table, which is saved somewhere else, and this is the key to get that information from that separate from that other table. So that's a foreign key that you really can define on your database level. Then we also have unique constraints, which will define that a certain column, for example, can only, that's all the values in a certain column need to be unique. It will only allow one null value. That is pretty important, though. I had my fair share of annoyance about this one in the past, though. And it will create a non-clustered index in the end as well. Then we also have check constraints, where you, for example, can say, hey, if somebody is going to allow us to have the salary saved on an employee record, well, make sure that the salary can't go negative. So the salary always needs to be larger than 0, for example. That's what you can do with a check constraint. And then pretty much the one I really like to use in the past, which is a default constraint, which can help you to say, hey, you know what? If a record gets inserted into a certain table, make sure there always is a date insert available, and just make sure it gets this moment with get date, for example. That's what I really like to do in the past. Then, besides constraints, we also need to have a very small chat about JSON support. So since SQL 2025, there is JSON support included as well. Just know that JSON can take up, the JSON data type actually can take up to 2 gigabytes per row. There are plenty of JSON functions included nowadays for parsing and transformation of your JSON object. Then there are ways to just lost. Oh, there. You also have a way to create a specific JSON index. Yeah? Create JSON index, which really will cover all the paths in your JSON object without the computed columns. All right. So if we then go to the next slide, yep.
all right, let's talk about sequences and partitioning. So how many of you are familiar with the Microsoft SQL Server sequence feature? Has anybody used that? Go ahead and put that in chat. I'd be interested to know how many of you have actually used that.
That's a good
So
question.
the way I see sequence is, this is not a dig at SQL Server, but it kind of reminds me of the Access days where you would set, a number in a table and then you would auto increment or manual increment, right? Every time you create a record. And so it allows you control of the next value so you can generate it. I've actually found this to be quite useful when relating to or dealing with systems where you have to import a set of data and then move it between environments. So let's say that, I know I'm going to eventually put some client data in production. So what am I going to do? I'm going to block off and jump those production records up, say, 6 million records, then go back to dev and QA that data within those sequence numbers. And then I can eventually import that into production without affecting my primary key So sequence gives you a little more control on what you're doing. It also has other options, like it'll cycle, like it'll go from 1 to 10 and then 1 to 10 and then 1 to 10, or whatever set of numbers you want. So that's pretty interesting. And it also works on linked servers, it says here, obviously, because you can call that function specifically, and you know what that's going to be, and then you can insert that value back in there. Identity, however, it's only supported on insert. There's no cycling. There's no really pre-generation. It always goes and gets the next value and then inserts it. So if you're doing cross servers, you could potentially have set identity insert issues. So keep that in mind. Partitioning. Now, this is one of the things I do a lot, and I love doing this because it can give you a really good performance boost when you have larger tables of over 1 billion records. So in order to partition and properly align that, you need what's called a partition function. And the partition function essentially says, hey, where am I going to put my data? Along with the partition scheme, those work hand in hand, and then those are applied to your table when you create that, and it specifies your value that you're partitioning on. So let's say you're partitioning on a date, you specify that date table and you put that in there. And then if you're partitioning on an integer, you can go ahead and do that, or a big int, and you do that as well. Just be sure that when you're creating your partition, you also align your indexes with that, because what will happen is if you don't, your data will not live all together in the same partition function and scheme. So it'll actually live in a different file group, excuse me. And then when you try to move your partitions, the data won't be aligned with it. It can cause problems. This is a great thing to do also for archiving. Let's say you want to archive your data or move it to a different system after using it. Partition switching is available. So you can literally grab that whole chunk of data from, like, say, last year or last month, and within a matter of 2 seconds or less, switch that data out, and it's now moved and outside of your main table. So it's a great feature for, archiving or moving data out that's no longer needed. The other cool thing for maintenance is you have the ability to rebuild your indexes per partition. So you can minimize your maintenance window by that. And then once you're done, as long as you're not going back and editing that or changing that partition, you don't have to run maintenance on that partition going forward. That allows you to reduce your maintenance window as well for that. And then sliding window, you can actually create a sliding partition scheme so that you can manage your data a little more efficiently.
Whew, that already was quite some information, but let's continue with module number 2. So in this module, we're going to focus on programmability objects. So what we're going to talk about mainly is about how can you use views, how can you store procedures, different kinds of functions, and so on. So that's what we're going to dive in right now. If you have specific opinions about procedures, views, and so on, please let them know. Just share them with us. So first things first, let's talk about views. So views basically are virtual tables, which simplify access across, which simplify access and for security and abstract schema changes. I have been using my fair share over the past few years, though, mainly in migration projects, but they can become very handy. There basically are 3 different types of views. We have standard views, which basically can encapsulate a query with complex joins. You can grant select on a view without exposing the base tables, which is pretty useful and which might help for security as well. And there always is the with check option, which can prevent inserts violating the views where clause. Then we have index views as well, which basically are materialized views. So what is interesting about them, You can create them, or you create them with schema binding, which also will provide a unique cluster index. And it will physically store the result set. So you can use that result later on for aggregation heavy reads. That's basically the use of that. And then it auto-maintains, or it's auto-maintained on DML. But make sure that you do consider write overhead. The last one is partition views. In all fairness, I might never have used partition views. Did you, Jeff?
Once or twice, but it's not very common.
No, it's a pretty specific use case, though.
Yeah.
Anyway, what I do want to share is one of the best practices. So one of the best practices is please use schema binding to prevent accidental base table changes. And please make sure you don't write select star in your views.
Yeah, who does select star? Select star is not something you should do as a developer, right? Yeah. Why? Do you know why? I wonder if anybody in our audience can tell us why you shouldn't use select star. That's a good one.
Yeah, that really is a good one.
We'll check the comments here in a minute and get back to that one. see what anybody has to say.
Why schema binding in the past, in my case, for example, when developing data warehousing solutions, I've been using my fair share of views as well, just to being able to process some data, to prepare some data with queries and views, and then get them through my pipelines to get my final results in my data warehouse. And if you are changing something in one of the base tables and forget to adjust the view, well, then your view is going to fail in the end. If you use schema binding, well, you won't be able to make the change without adjusting the view. So that is pretty useful. And in all fairness, the final thing about views is it really can help to layer specific security rules as well. Anyway, please don't use views nested beyond 2 levels, just for readability. That might be a good one as well. Anyway,
yeah, and if you can get away without using views, do that. Yeah, because that's always the best solution.
Absolutely.
Maybe use a windowing function or CTE or something.
Yeah, that's something we're going to tackle a bit later on, though.
We are.
Yeah.
Hey, so a couple comments we have from the crowd about select star from the attendees here. So seek versus scan, obviously that would play a role into it. Yes, so that's not the total reason why, but that definitely would be a result of selecting star versus not, because it would a star would scan the entire table versus a seek if you selected 1 or 2 columns that were indexed, right? Someone says the results aren't deterministic, right? Same sort of pattern there between seek and scan. There was a couple other comments here. You can't guarantee order. Well, actually, the order is only guaranteed if you put an order by on the query, right? So there's no guaranteed order unless you do that. It's actually been kind of funny to watch some of the tables. You can run the same query 10 times and it gives you 10 different result orders. Performance and capacity consumption. I'm going to say performance for sure. You're definitely correct there, because obviously if you select the whole table, you're getting a dump. So I'm going to say, obviously the index and seek, the seek versus scan is probably the closest one there. I think to our answers that we got. And yes, you definitely want to seek when you are running a query as much as possible. Don't scan the whole table. So when you select star, it's going to grab everything, and you're probably not going to need everything for your query. So again, when dealing with SQL Server, especially with high transactions, you want the smallest amount of data returned that you need, exactly what you need, a minimal amount of what you need instead of everything. So definitely don't use select star. Now, if you're just coding, on your desktop and testing, that's fine. But when it goes into production, be sure that that's changed.
Yeah.
All right, now on to stored procedures.
Yes. So stored procedures is something I've been using in the past very extensively, though. What is a stored procedure? It basically is, you can compare it with a server-side compiled program. So you write a lot of rules and logic that you want to, or for example, procedure that you really want to execute to process some data. You can encapsulate that one in a stored procedure, which can then be executed throughout a data pipeline somewhere. So what are the core capabilities of a stored procedure? Well, you can play around with input parameters. So you can parameterize your procedures. You can use output parameters to get the data back out to provide it somewhere else. You can use return values. There are quite a lot of possibilities. In all fairness, which thing I really used a lot were temp tables. So just saving intermediate results into temp tables, which are just removed as soon as you close down your session, for example. And then what I'm still on the fence on, though, is a dynamic SQL. Please be aware there is something to say about dynamic SQL. It can be very useful, but watch out for dynamic SQL. It is helpful. It is very powerful, but I've been trying to use it to the limits. And if you then run into issues, it can be very challenging to debug as well.
It can also be a security concern, so keep that in mind too. If it's not handled directly.
Yeah, that's right.
I saw a comment come through in the chat. I just wanted to shout out here. Someone suggested top 1 is a good common ground for that, and I'm going to say another key tip is if you are trying to get a top set of data, top 1 is actually still going to scan the entire table. So that's not really the best performance option out there. The best performance option is if you have to, like, say top 10, top 25, or you're doing some sort of paging. Don't even use a CTE now. If you have the newer versions of SQL Server, there's actually something called offset.
Yeah.
And if you use offset and specify your number of rows in your page, that is actually extremely fast, faster than previous. It's about cuts the execution plan in half when looking for that subset of records. So definitely use offset instead of top.
That's a good one. Then to continue, it's very useful to use try-catch blocks in stored procedures, just for transactions in general, for atomic operations. And then you can use execute as for security context switching or set no count on, for example, to suppress row count messages. So those are just core capabilities. If we talk about design patterns, though, stored procedures are often used for CRUD operations, so create, read, update, and delete. Therefore, it's used very commonly for ETL pipelines, as I mentioned before as well, for report generation. Typically done in combination with dynamic SQL, though, in some cases, and then many more, of course, as well. What is important, though, is, and what I really want to mention is, if you ever run into performance issues with stored procedures, it might be have something to do with parameter sniffing. What's parameter sniffing, and I don't want to get into this one too deep, though, is that the first time you execute a query, it is going to generate a query plan which might be cached for later use on SQL Server. It might be that it is going to, save your first plan, which is executed for a specific number or range of IDs. And then it's saved a certain query plan, which is actually not really optimal to execute the SQL query in general. So if you ever run into something that smells like parameter sniffing, you can try to use option recompile or optimize for when there is plan skew. I know it's very, very fluffy though, but it's definitely something you need to take a look at and be aware of, what parameter sniffing is.
And I think in the latest version of SQL Server, there has been some new additions to help eliminate most of that parameter sniffing, which is nice.
That's cool. So that was
all right. Oh, sorry. Are you finished?
No.
Oh, sorry. Go for it.
So now that we had views, store procedures, we need to have a chat about user-defined functions as well. There typically are three different ones. Well, actually there are two, but here they're split into three though. First things first, we have scalar functions. A scalar function basically is a SQL function that you can write, which will return exactly one result, one value. You can call a scalar function in a select clause, in a where clause, in a check constraint, and apparently I learned something new today. I wasn't aware that it was able to use it in a check constraint though. That's cool. That's a scalar function. Then we have inline table valued functions and multi-statement table value functions, which basically is, and if we just take them back together, a table valued function is a function where you're going to return a table as a result set. That's what you're going to do there. So, for example, as a good example for a scalar function would be, well, convert the dollar value to euros, for example. In a scalar function, you're going to say, hey, $1 is, well, let's say €1, just to say something. In a table valued function, you might be saying, hey, provide me a table of all the conversion values for the different currencies, just to give an idea of what you can get with a specific type of function. So just that there are different types of functions available as well.
All right, so we have a few minutes left here. We need to get through a few more slides quickly. So let's talk about triggers for a minute. So there are a couple different triggers. There's DML triggers, DDL triggers, and logon triggers. I believe, and I would guess that most of you are familiar with the DML triggers, right? So when you insert something into a table, you can fire a trigger on insert, update, or delete. You can run some sort of checks. I think a lot of times in the past, there's been a lot of audit tables used in triggers. Now we have temporal tables, which can kind of take that feature away from dealing with triggers, which is really nice. So a couple best practices here. Keep trigger logic minimal, very simple if you have to use triggers. Try not to use triggers as much as possible. Go ahead and put that in your store procedure if possible and handle that logic there. And then obviously don't do any nested triggers because that can start causing some potential unwanted events happening and other processes happening without your, say, expected knowledge, or sometimes, you forget you have multiple triggers, especially if there's no results returned, like no count is on for those. You won't even know it's happening unless you're really digging into the code. So it also says never rely on trigger firing order, right? So just because you call one and then another doesn't necessarily mean it's going to fire in the right order. So use temporal tables as an alternative for auditing for sure, and obviously test with multi-row operations. All right, so the next module, we're going to talk about writing advanced T-SQL code. So CTEs, window functions, JSON processing, regular expressions, fuzzy matching, graph queries, and structured error handling. So CTEs are a great tool if used correctly and distinctly, right? So being able to, filter through a set of data is very nice, especially when aggregating or trying to remove duplicates. So there's definitely some things you can do there. You can use them with selects, insert updates, or delete statements, which is also nice. I use CTEs quite a bit, or windowing functions with this. Be careful though, because there is some max recursion issues or limitations there. So be careful with that. So you can also stack CTEs. Now that's some really advanced stuff there if you're stacking CTEs. So be careful. Obviously, test each layer. And then subqueries. So you can use subqueries as well. Just be careful with subqueries, and use those sparingly in your queries if at all possible. Windowing functions, like I said, I use a lot of windowing functions, CTEs, which is great because now I want to say since 2022, there's some newer features in SQL Server like lead and lag for offset, right? So it'll give you the value before, the value after, which is pretty nice when trying to deal with queries. So you can like see when a value changes and then do something different in your windowing function, or assign it, a rank, or assign it a row number, which is pretty awesome. So a lot of new functions here. You can see the syntax down there at the bottom of the screen. It's just over partition by column, order by column, and then you can do rows between unbounded preceding and current row. There's a lot of different flavors and options there for syntax for your windowing functions. And the new thing about windowing functions is you only have to define it once. You don't have to define it at each column level now in your query, which is a new feature. So define it once in the bottom of your query, and then you just use the alias you assign to it up at each column level. All right, some new JSON and XML processing in T-SQL. So I actually use a lot of these JSON functions because you can actually select your tables out of SQL Server directly into a JSON object and then pass it on to your API or application. So I've used this a lot. So for JSON path allows you to specify every column name you want out. And if you join the two tables, SQL Server will actually create that relationship in that JSON object as you select it out. So it's really nice. For JSON Auto, it just takes whatever field names you have there. Open JSON, you can actually look at either a file or a field that has a complete JSON object in it. You can then extract objects from that using JSON value. You can get a subarray of objects using JSON query. You can actually modify them if it's in place and that's what you want to do, modify those actual objects. And then there's JSON object and JSON array, construct JSON in SQL 22 and newer, which is nice to use there. So you can actually return the JSON object and a value now, which you couldn't before. And then there's a new isJSON validation property that is available for you to check to make sure that the JSON is valid as well. The same thing applies for XML, XML for path, auto, raw, and then you can do your queries, you can get your values, you can modify it, and you can look at your nodes. So similar functions are available for each of those as well. Now this is awesome stuff. I don't know if you've ever tried to use a regular expression, in code or in SQL before, but how many of you out there are attending this session, how many of you have used regular expressions in your code and wished it was available in SQL Server? Well, guess what? It is now available in SQL Server 2025, which is awesome. So you have all of these regular expressions that you can use and search for data or filter for data or convert fields on the fly. This is an incredible new feature for developers and for anybody running queries inside of SQL Server. So I'm really happy about this one. Then there's fuzzy string matching for all of you developers or data analysts who are trying to clean up your data. Doing fuzzy string matching is a great new resource that allows us to clean up our data a little more. So there's distance similarity, there's soundex, there's difference with the scale, and then you can combine those with threshold. Hey, where edit distance similarity is greater than 80, right? So you want to make something that's like almost there, and then you can go back and fix it, right? Or correct it. So this is really cool. I really like this new feature. All right, and then graph queries and error handling. So for graph queries, you can create your node tables, you create your edge tables, and then you can do your queries to match them and find where those matches are, and then you can stage those matches. And if you have a graph visualization tool, you can actually throw it up visually, and then you can actually watch how everything connects together, which is great for social networks, or if you're dealing with fraudulent transactions, or you just want to find how something relates to each other. I've used this, and this is pretty cool. And then try catch error handling. Did you want to cover that real quick?
Can be, but then I will make it as short as possible. Yeah, it's just a great way to, for example, in-store procedures to catch specific SQL issues or value issues, and therefore the try catch blocks can be very useful. So
and now I think you can actually create your own custom errors now, which you couldn't before. You had to make sure it was in the MSDB table, I believe. So now, I mean, again, I think this has been around since 2012, but it's nice because you can create your own error messages, right?
Yeah.
So that's very nice. All right. What else do we have here? AI assisted database development. Who's ready for some AI assisted database development? I know I've been using a bunch of AI lately, which is pretty cool. It's making things go a whole lot faster for me.
Yeah, for example, where I've been using GitHub Copilot for in SQL, and you can get it in Management Studio 2022 or in VS Code. It doesn't really matter. I like to get some help with code completion, with if I need to debug queries from other people, with some just asking Copilot to explain queries to me, what they're doing, helping them to optimize them. The easy thing is I can just write it in natural language. Hey, I want you to help me with explain this query or optimize this query. It's running quite slow on that side. What can you advise? And that probably will come with a solution, hopefully, though. It's very useful for those kind of things. I mainly use it for code completion, though. It saves me a lot of time.
Yeah. Still be careful, though, because sometimes, as they say, AI can hallucinate, right? And so it may not be exactly what you're wanting or thinking. So be sure to double check that. So
that exactly is one of the caveats, though.
Yeah.
Just that it's either Management Studio 2022 or VS Code with an extension. And then for GitHub Copilot subscription, the free tier gives you 50 requests, and it will respect your database permissions. So Fabric Copilot for SQL, some kind of the same. You will have a chat pane to ask natural language questions to your database, which gets or will be translated to T-SQL queries or documentation. It can help you with code completion in Fabric as well, with Fabric Copilot for SQL. It can help you with fixing queries. That's something it can do as well. And as mentioned, more or less the same as GitHub Copilot. It can help you with explaining what's going on in a specific query. So it's very similar to what you can do in VS Code or in Management Studio.
All right, so MCP, I'm sure you all have been hearing about that a whole lot lately. So MCP essentially is a open protocol, right, that allow AI to interact with your database or databases. So you have AI client, which is VS Code, Claude, Chat, GPT, Copilot. Then you have the server, which has your data API builder on it, and then you have your SQL server. So the MCP server essentially is a collection of your tools, which allows you to then work with your data. So here's a quick list of those MCP server tools. So list tables, read data, create item, update item, delete, execute query. But again, it's built on, the existing structure and security of your database, right? So no data leaves your environment. It's in there. It runs alongside your database, right? It interacts with your UI and allows you to make use of those tools and improve and speed up your development processes.
Well, now that you've been talking about all these different tools that we have in our tool sets, the real power actually comes from combining all those AI tools in your development workflow. Alter your things in Copilot, connect them via MCP, analyze in Fabric, govern with role-based access control and instruction files. A best practice, though, is please make sure to review AI-generated SQL before you move it to production. As Jeff mentioned as well,
absolutely.
AI can still hallucinate, provide incorrect results. So please make sure you are the smart one in the middle. Always revise the suggestions that AI makes. And it might be a good idea, though, to start with read-only access for your AI agents.
Yes, I would say that for sure. I don't even know if I would ever change that, honestly. Or if I did, I would put it in a staging environment or something first and do some severe testing on that. Make sure all of my guidelines or guide rails are set and tested very well. All right, so when to use what? Decision guide. So here's a couple items here. If you have high throughput OLTP with latch contention, maybe consider in-memory OLTPs with natively compiled store procedures. For audit trail, data forensics, and compliance, use ledger tables, right? They're updatable or append only, depending on what you want to use them for. Query external storage without import, like if you want to look at data without really loading it, or you want to just look at the data and then pull a subset. External tables with Polybase, using the REST APIs that are available. Complex relationships, use a graph table, right? Use the edges and nodes there. And then for reusable read-only access layers, you can use views, right? Standard or index for aggregation. If you need to use or have complex pattern matching text parsing, hey, use the regex functions built into SQL Server 2025. If you have some AI-powered authoring that you need to do using GitHub Copilot and SQL Management Studio 22 or VS Code is great to use for an assist. And then AI agent database operations, you can stand up SQL Server MCP server, use the data API builder, and use your RBAC controls and get you a lot of AI there. All right, so takeaways from today. Let's run over what we went over briefly. SQL Server runs everywhere, on-prem, Docker, any flavor you want, and even in Fabric. Match the table types for your workloads. That is key, right? The right tool for the right job. Same thing with indexing. Choose the right type of index. Make sure you have a clustered index for OLTP. We didn't really cover Columnstore, I don't think, too much, but Columnstore for analytics is a great aggregation, and also it allows you to reduce the space for your index as well. Encapsulate all your business logic, or not all your business logic, but all your logic inside of your store procedures and functions. Don't leave them in code. This allows you to have that code pre-compiled for faster execution inside of SQL Server. Use Windows functions and CTEs. Can replace the complex joins and subqueries that you might have written already, and they perform a little faster. SQL Server 2025 adds your native regex and fuzzy matching, which is awesome, and new JSON data type is also available. And then GitHub Copilot and Fabric Copilot accelerate your authoring, and it's schema aware and can help you search and troubleshoot and write code inside of your environments. And then MCP connects AI agents to databases safely with your RBAC and standard protocols. So that is an awesome tool there.
Well, that being said, I think we are on time at this point. So where are you waiting for? Start preparation for DP-800. As you know by now, it went GA. Make sure to review the study guide on aka.ms/dp800/prepare or scan the QR code. Make sure to practice and get hands-on with T-SQL. Will be fairly important. Make sure to review all available preparation sources and complete the Microsoft Learn modules. They are very beneficial. If possible, take a practice assessment and schedule your exam, of course.
I think there's two more sessions upcoming in this series, so you can check those out there on May 26th and June 10th. You can register and watch on demand after the session. You can watch this just like today here. There's also SQL product roadmap influence capability here. If you want to join the SQL user panel, go ahead and scan this QR code or hit this URL, aka.ms/join SQL user panel, and give your feedback to Microsoft for the next feature set of SQL Server. And don't forget to join your local Azure data group or find one online and join it across the world. There's a lot of good content out there, a lot of good organizers, and they would be happy to have you involved in your local user group and attending sessions and supporting the team, and also learning. It's a great place to learn. All right, and a new Data Days event is coming soon, so if you don't want to miss out on those sessions, join there at that URL, aka.ms/data days, or hit that QR code. We'd love to see you out there as well. Thank you for joining our session, and we will see you later.
Thank you all for joining, and thanks again to our speakers. This session is a part of a series. To register for future shows and watch past episodes on demand, you can follow the link on the screen or in the chat. We're always looking to improve our sessions and your experience. If you have any feedback for us, we would love to hear what you have to say. You can find that link on the screen or in the chat. And we'll see you at the next one.